Okay, our theme for today will be about the new capabilities in CreoParametric. It's called Lattice feature. This feature is available only in Creo 4.0, and we want to compare this feature with a topology optimization tool called ProTOpCI from the company CAESS. This is a partner of PTC. But let's have first look at the agenda. First I'd like to introduce me. Then I'd like to give a little overview about the company I'm working for, GIA Informatic, and then let's have a little look about the new capabilities of CreoParametric and CreoSimulate, what's new in Creo 4.0, how can we use this new lattice feature in CreoSimulate to simulate, to optimize the structural behavior. Then we are going to have a little overview about the tool from CAESS. This is a, let's say, real topology optimization, and let's see the advantages and disadvantages of those two capabilities. And of course we want to spend the most of the time in the applications to get a feeling how easy it is to use those new features. And at the end of this 1-hour webinar, you will get the opportunity to ask some questions. Because we have quite a lot of people in this call, I please you to do that over the chat panel or send me an email later on. Okay, let's start with me. This is me. A nice picture from the old days. My name is Urs Simler. Urs means I'm a Swiss guy. Urs is an old Roman name. It means the bear, not the beer, the bear. And Simler means I'm focused on the simulation tools within Creo. So the simulation tools within Creo, within the PTC environment, are those capabilities, CreoSimulate, mechanisms, animation, mannequin, BMX, Spark analysis extension, which is now, or which is substituted right now with a new tool, and there is also mold analysis and MatCat. These are the PTC tools in red. And in blue, we from GIA Informatic, we also are a reseller of Mentor graphics. That means we can also give you information about a nice tool called FlowFD, integrated CFD simulation in CreoParametric. And as the last tool we are working with at GIA is this topology optimization capability from CAESS, and I will show later on live a little bit about that. I have about 28 years of simulation experience in the field, and 20 years of that experience comes from PTC. I was working there as an application engineer, mainly with ProMechanica, Mechanism, and all that tools up here. Right now I'm working for a company called GIA Informatica AG, so don't be afraid, there is no C, that's a G, and GIA Informatica is located in the middle of Switzerland. We were founded 88, and in the middle of Switzerland means here the yellow point is Zurich, the blue point is Basel, and the green point, that is our capital called Bern. So we're in the middle of our country, about 150 people are working for GIA, and we are the, let's say, the daughter of this Müller-Martini group. Müller-Martini group is working or is producing, let's say, machines after the printing process. That means it's producing cutting machines, handling machines for newspapers and that kind of stuff. And GIA Informatik belongs to Müller-Martini, and we are working on SAP solutions. We have we are bringing IT services. We have an own data center, and a group within GIA is dealing with CAD, CAM, PLM, and CAE. We are doing consulting, implementation, support, and services with our partners, and in the CAD or PLM environment, we are dealing mainly with PTC, and beside PTC, we have products from Mentor Graphics, CAESS, or other companies like TechSoft or Software Factory. Okay, that's all about the company I'm working for. Let's talk about a little bit these new capabilities of the lattice structure for additive manufacturing within CreoParametric. These features we are talking about right now is only available in the newest version. So what I'm talking about is only available in CreoParametric Simulate 4.0. And with this new feature here, it's an additional license, additive manufacturing license. We are getting the capability to create within CreoParametric 2.5D and 3D lattice structures. So what does that mean? With these pictures we can see the components we can create. So that means inside our components we can create these lightweight structures for 3D printing in order to get nice parts for 3D printing. That means the printing process will not last that long when you have these lattice structures, and you can save quite a lot of weight and costs for the 3D printing process. These are, let's say, some examples of these new lattice structures. These lattice structures can be influenced with references. That means within that volume I want to create my lattice structures. That means maybe within here, that area, I want to create lattice structure. It means I can influence the cell dimension. So it means how thick is my beam, what's the cell shape, is it a square, is it a honeycomb, something like that. And as I told you, we can also influence the diameter of our structures or the dimensions. And in these examples here we can also bring in here some balls where the beams are connected. And in addition to that, we also can set up the density, influence the density. That means maybe in that regions we want to have more density than in that region here. But I will show that later on how that behaves. Okay, that are the new capabilities of Creo 4.0, CreoParametric. And this information can also be used in CreoSimulate to see the structural behavior of this new lattice structure. We have here two capabilities. We can use the full geometry to make the simulation. That means we are taking here this volume geometry, and we can, let's say, calculate our stresses with the help of that volumes, and we can see here the detailed stresses in our lattices. Beside, let's say, the full representation, we get the capability within CreoParametric to create a simplified representation. That means we just get here a grid with some lines. behind that lines there is the information about, let's say, the beam thickness, and we can use these beams here within CreoSimulate to calculate, let's say, the behavior of that one. Let's say the disadvantage or the advantage of that beams or shells is that the calculation runs through very quickly, but the disadvantage is that we do not get, let's say, the perfect stress behavior. Another capability of this, let's say, parametric lattice feature from Creo is that we can use those parameters to do some optimization. But we just can select, let's say, those diameters, sizes of our grids to do some parameter optimization. That means within CreoSimulate we will never be able, let's say, to take away here some beams or to take away some shells in order to get, let's say, a bionic, or in order to get a lightweight part. So we just can modify the dimensions and see what happens, and if we might have, let's say, 3 or 4 parameters, we can do a parameter optimization. The advantage of that solution is that we get a nice representation within CreoParametric, and we can use that representation for CreoSimulate. And the disadvantage is that we do not have a, let's say, real bionic optimization or topology optimization of our structures or of our lattice structures. And as I told before, in that region we will not get, let's say, realistic, or will not get nice stress behavior. Okay, these are the capabilities only available in Creo 4.0, and we need a special license for that one to create it. And of course, to analyze it, we need an additional CreoSimulate license. Let's have a look at the real topology optimization. Let's call it Bionic Optimization. And for that reason, you can use a tool from a company, CAESS. The tool is called ProTOP or ProTOpCI. And with that tool, we can do, let's say, bionic behavior of our component. Imagine if you have a component, maybe it will load it in that area. You know, okay, you will have more force on the left-hand side than on the right-hand side because of the geometric situation. That's easy to recognize by ProTOpCI, and it will optimize those lattices inside our component by just adding on the left side additional material, and on the right side it will take out some material. So that means with that capability we can, let's say, create a flexible configuration in order to get a lightweight bionic part. Here there is another example of a turbine blade, how we can, let's say, create inside the turbine blade some meaningful lattice structures. Within ProTOpCI, we do not have only, let's say, to create lattice structures, we can also deal, let's say, with solids. I will show that later on. In addition to solids, we can, let's say, deal with shells. That means, okay, we can say in that regions we want to have shells. They can have a thickness between that values, and if we type in for the minimum value here a 0, then ProTOP knows it also can take away that shell with a 0 value. And the interesting thing is also about setting up lattice structures. Within ProTOpCI we also have the capability to create different lattice shapes, and with the help of that lattice shapes, you'll see later on, we can create here a real bionic topology optimization. That means we can satisfy multifunctional applications, like here an implant of a bone or additional things here. And we can use the geometry directly for 3D printing because we have here some capabilities to make a smooth mesh and then to take that smooth mesh for the 3D printer. The advantage of that tool is that we have a real topology optimization, we have a bionic topology optimization, and we are getting with that tool very innovative design ideas. The disadvantage is right now we, let's say, only get tessellated geometry, and if we want to bring that back to CreoParametric, then we have to remodel that component if we want to have, let's say, a smooth or a parametric B-rep geometry. In the future here, there we will bring in ProTOpCI, we'll bring another capabilities where we can bring over the geometry with a OBJ file to not flex modeling, to the surface modeling. I will show that later on also. So let's go right now for the live demo. I will show first the capabilities within CreoParametric to create this lattice feature, to use them within CreoSimulate, and in the second session I will show the capabilities of ProTOpCI. So let's go first for CreoParametrics. So I will change my application here for CreoParametric. In CreoParametric right now 4.0, in that region under engineering, I have the new capability to create lattice features. How will that work here? You go for lattice features and then you'll get the information, oh, do you want to create a 2.5D or 3D lattice type? I'm going first for 2.5D, and here on the cells I can, let's say, take here a square, and as a reference I say, okay, I want to convert that solid and I want to keep maybe a shell around that solid of 16 millimeters. That means right now if I go for the preview button, I cannot see everything, I have to create it, and then I can see here red highlighted these lattice features. I'm going back for redefining it, and I want to maybe make a smaller size here by just scaling it by 0.5 millimeters. I'm going here maybe for my cell, and I want to change it to a hex shape. And here under references I can also define where starts my first cell. So I'm going here for first cell. I'm selecting a coordinate system, and I also have the capability to exclude those two surfaces from my lattices. I'm hitting the preview button, and I can see right now the behavior of this 2.5D lattice feature. These shells here could also be used by CreoSimulate to do a simulation, but right now we want to go for a 3D lattice structure, so I'm changing to 3D, and you can see, okay, down there also the shape will be modified. I want to increase the size of my shape. You see, okay, it will be increased. I will decrease here maybe the ball diameter to 30 millimeters. I'm going back to 20 millimeters for my cross section size. It's a circle, and I'm going back here for my cell, and that in that environment I can maybe change the size of that cell in Z direction to 70 millimeters, and I can take out here some of the beams in order to get, let's say, that behavior. I'm assigning that situation, and I'm getting 87 beams here, and in the middle here we see these walls. Okay, I'm going back for redefining it, and I'd like to, let's say, influence here under the density tab. I want to influence, let's say, the dimensions of my component. I'm creating here a new set. It starts maybe from that surface here, and over a distance of 500 millimeters I want to change with that ratio here. I want to change here the values, and therefore when I'm taking that one, you can see it right now, the dimensions here on the right hand side. The thickness of my beams are much more than here on the left hand side. That are more the capabilities of this new feature called here lattice feature. And I want to use these new capabilities on a component here. I want to create here a component, and on that component I want to create here in the inner side of the component some lattice features. Therefore I'm going to select here those inner surfaces. I'm selecting also the boundaries around it. Okay, that's a boundary around, and I'm going here for my lattice feature. Okay, I can see right now my lattice feature. I want to scale it by 0.5. I'm going to change my cell shape to hexagonal, and here I want to create the first cell regarding to that coordinate system. This coordinate system is not here, let's say, in XY direction. It's a little bit to that size. So that means as soon as I'm selecting that coordinate system, here, of course, I have to select it down here. You see, okay, this guy here moved by about 6 degrees. And in that environment, I want to also modify my shell by modifying these beams here. I'm selecting the size of this hex shape. Okay, and in Z direction I want to have here maybe 12 millimeters. And I'd like to round this radius, or I want to round it here, and I don't want to have a ball inside. So right now it's not rounded, but if I'm going back for my cell and I'm activating the round radius, I can see here my roundings. Okay, I can press here the preview button. I can see here the shape, and I can also, let's say, use here instead of full geometry, I can use a simplified geometry. That means simplified geometry is created very, very quickly. And now I can go here for my simulation application in order to simulate my component. I was setting up here, let's say, my constraints, and I was setting up here on that cut surface a so-called symmetry constraint. I was bringing in here some loads, and with the help of that loads, and of course I was assigning here a material. Okay, I can set up an analysis here. I call it maybe ST beams. Okay, and I run this analysis. And you see right now this analysis runs through very, very quickly because there are simplified shells here. It took me about 5 seconds. Within CreoSimulate you can also activate here the beams in order to see them all the time. Now the analysis was done, and I can have a look at the results here. The behavior of that component, we see the displacement behavior, we see stresses and so on. And in Creo 4 you can, let's say, spin around all the 4 windows together. So I just want to see maybe here just the stresses, and I can see here, okay, in that area the stresses are not that accurate, and therefore I want to use right now, let's say, the full representation from CreoParametric for my simulation. I'm going for redefining this lattice feature, and instead of simplify the geometry, I'm using the full geometry. And of course, right now with the full geometry, when going for CreoSimulate, the analysis will take a little bit longer. So I'm checking here the analysis time. Before we had about 5 seconds, and right now we are around 12 seconds for meshing, and with solving we need about, what's that, 20 seconds, 30 seconds? Yes, it's maybe factor 5 or 6 more. And of course here when I'm going for my results, just showing here the stress results of the volume model, and beside that I'm showing the stress results of the beam analysis. And here I'm going for scaling the values of the stresses between 0 and 700 megapascal, and I'm going to tie both legends. And of course here I'd like to zoom in to that area, and I think you can see, okay, on the left hand side I will not get here accurate stresses. I can check the stress behavior here by viewing the max. It's about 530 megapascals, and on the left hand side we see, okay, it's here around, come on, 600. Now I have to zoom in a little bit more to have that one view max. It's about 600 megapascals. So there is a difference of about 15%. But that should show, or this demonstration should show, the capabilities of this new lattice feature within CreoParametric and within CreoSimulate. Let's go back for the PowerPoint presentation, and the next feature we'd like to see the capabilities of the Bionic, or of the Topology Optimization, called ProTOpCI. And here we want to see how we can set up that model, and what are the capability to create a new design idea. Okay, let's go back for CreoParametric, and in CreoParametric first I'd like to show again the behavior of topology optimization. Therefore I'm opening again here the simple part here. Okay, and then on that simple part I'd like to create a topology optimization from scratch. I'm going here for CreoSimulate again, and the first thing I'm doing in CreoSimulate, in the native mode, I'm doing a normal static analysis by applying a load of 45,000 newtons to that side, and by applying a constraint, displacement constraint, on that size. Of course here material steel is already set up, and I just have to set up a new static analysis, and I have to run that analysis. Of course here I can check the analysis behavior. It's already done within 6 seconds. And I'm just going in the CreoSimulate native mode. That's not, let's say, topology optimization, what I'm doing right now here. That's normal structural analysis. Here I'm getting the stress results. And of course, within CreoSimulate, I can, let's say, just show the high stresses, and that means, okay, these areas here that are the low stress areas, and I could, let's say, cut out those areas without loosening a lot of stiffness. And this is the topology optimization, is doing that kind of stuff. It's cutting out the areas without stress. Then it's analyzing again, and then it will, we'll see that later on, it will also add some materials later on in order to get a lightweight bionic part. So that means within CreoSimulate we just can do the very, very first step of topology optimization, and it's not automated at all. So you have to do that by hand, and it would take you ages to get a nice bionic part. Therefore we are using this simulation entities for our topology optimization. We would like to, or we have to set up a model here, and we're doing that in the FEM mode. That means FEM mode is available for everybody who has a license of CreoSimulate. So there is no additional license to prepare a topology optimization analysis. And now I'm preparing this topology optimization analysis, and I want to have here on the outer side, I want to have here, let's say, a shell geometry which will be kept. I can define that by creating here a so-called volume region. I'm creating here a volume region by just doing here a offset. I'm doing an offset of that loop, maybe by 16 millimeters to the inner side. And this blue volume here will be assigned later on to be optimized. And this will be assigned by a specific material. I'm just taking the old material here, I'm copying that one, and I'm renaming that material maybe to steel underline fix. And right now I will assign that underline fix material to my component. So I'm doing it now, underline fix to my component, in order to keep this shell topology around my part. This will be known by the topology optimization later on automatically because of this underlined fix. I'm creating here a new analysis, okay, maybe called analysis something, okay, and an important thing is to, let's say, control the mesh again. This is, let's say, the standard mesh in FEM mode, and this mesh is too coarse for topology optimization, because later on ProTOpCI will detect elements with low stresses, and it will deactivate it, and therefore these elements have to have a, let's say, a small size. And it's very easy, let's say, to control this size of that meshes. I'm just going in for my component, and I want to have elements less than 11 millimeters, and that means right now if I'm meshing the component again, I can see here a very dense mesh, and I will use that dense mesh within my topology optimization tool. I'm just connecting the model here with ProTOpCI in order to start my optimization. I can see here my model, and with this color coding, ProTOP shows me, okay, the blue area here is free, that can be optimized. The gray one Here, the shell around it, it's not allowed to optimize it. And here with that colors, it shows me there are some constraints, there are some loadings. And I just can go here now for optimization, and I'm starting, let's say, the optimization. First, it's calculating, as before, the stress behavior. I can see right now the stress behavior of my initial step. And now ProTOpCI starts here taking out the material where not needed. And it will just, let's say, take out the material in the low stress regions. And maybe on that area here, we can see ProTOP start to create, let's say here, a bionic topology. And in many cases, I'm just pausing here this session without saving the shape. In many cases, I know how this component will be manufactured later on, and I can define that within my environment. I'm just adding here a new constraint set to the optimized blue geometry, and here I have several capabilities to define, will that component be a casted part, will it be milled or something like that, and by defining a bidirectional opening, that means, okay, this component will be lasered maybe from that or from that side here. Okay, and by doing that and starting the optimization again, showing again here the stress behavior, okay, it will start to take out those material, but it's not allowed, let's say, to create these bionic structures, because it has to keep in mind the optimizer only, let's say, cutting in that direction here is possible. Okay, let's have a look here at the stresses. And now it's creating my part by just cutting out in that direction. And here in that area you can, let's say, set up the target of your optimization. This is just, let's say, the behavior of a normal part. Now we are going for the same part. We created lattices in CreoParametric and we controlled them in CreoSimulate. We're opening this nearly the same part, and we want to now create the Bionic Optimization. So with that component we're going for simulate again, and here I set it up the model. As before, here I have a normal material and a fixed material. Let's say the normal material indicates this area can be optimized. We have here some loadings, and this is whole left constraint, and the other one is whole right constraint, these two, and this is the mirror symmetric constraint. I brought in 5 load set. That means, okay, this component will be loaded in that, and that directions. And I brought in an additional load set. That means I loaded those areas with a little pressure, and this indicates that later on in ProTOP, the topology optimization, we want to create on this red highlighted surfaces, we want to create some shells. And then I created here an analysis, because I have, let's say, 5 load sets. I created 5 analyses, and I created here an analysis for my later setting up of the shells. And I'm going with that model to my topology optimization. This is live demonstration, so it's taking maybe 10 seconds. ProTOP opens again. Okay, and I can see here the model. Again, color-coded. Blue means this is free, let's say, area. Gray means it's not allowed to modify it. and the other colors are for loads and constraints. And now I'm going to just my optimization tool, and I'm starting the optimization without defining anything again. As we saw it before, we see here, let's say, the stresses. Come on. Okay. And ProTOP starts to cut out the areas not needed. Okay. But as I told you before, I want to create some lattice structures. Therefore, I don't want to start, let's say, directly with the Bionic Optimization. I want to define right now what kind of lattices I'd like to create and what kind of shells I'd like to create. First, I'm creating a normal constraint by adding here a new one, and I want to have here a plane symmetry, not to that surface here. I want to, let's say, rotate it by 90 degrees. Okay, I want to have a mirror symmetric part to that plane here. And in addition to that, I'd like to set up a configuration in order to get some shells and lattice features. I want to create shells here on those regions which can be modified, and by deactivating, let's say, this front surface and the back surface, I'm defining the size of my shell thickness between 0 and 1.5 millimeters. I'm going to apply that one, and I can see when I'm looking from front, okay, this is, let's say, the middle thickness of the shell. By typing in here a 1 plus 1, I will have the maximum shell thickness, and by typing in, I will not type in -1, I'm just typing in -0.7. Okay, I can see here a minimum shape of that one. Going back for 0, that means middle dimensions. Now I'm creating an additional lattice structure. Here I have my different types of lattices. I'm doing also a hex shape here, and the shape should have a size of about 8 and 12, and the thickness of my beams can be modified between 0 and 3 millimeters, and I want to have here the maximum roundings. And I'm looking here from that side to my component. I'm activating my cross-section in order to see my beam here. The beam goes right now straight or vertical, and by bringing here a little bit rotation of 6 degrees, you can see, okay, the beams goes a little bit to the right. And of course, again, as before, this is more or less the maximum shape of the beam, and let's go to the middle size of the beam. And we can see right now here, okay, with this configuration, we are getting here on, let's say, that area which can be modified. We can, let's say, change our volume or our mass between 0 and 37%. So that means later on for me, if I'd like to optimize my component in that area, it makes sense to type in a value between 0 and 37%. I started right now this optimization. I'm going here for my von Mises stresses, and I want to go here for maximizing my component or the size. And I can see right now, because the stresses here, let's say in that regions, are much higher then the stresses in that regions. ProTOP will let's say maximize those thicknesses here, and it will minimize, let's say, those thicknesses here. It's still on the way, it's still optimizing, and we can see right now it's also taking away the material in that region. And when I'm looking right now from front, this is live optimization, it starts to take away, let's say, the beams in that regions, because they are not needed. There are low stress regions there, so it's taking away these areas. And again, here in that area, it's also taking away the beams. And right now we can see we are quite close to our target of 23%. And just to tell you, you can also optimize the stresses on the cutted surface. You can optimize the maximum deflection. You can also optimize eigenvalues. You can deal with nonlinear material behavior. You can deal with pre-stress screws in order to get, let's say, realistic simulations. And right now, after 2 minutes, 2.5 minutes, we will get, let's say, a nice idea how could our shape look like. And you see right now the analysis finished, and now I can go for, let's say, post-processing. I can check here the geometry. I'm going to smooth my geometry, maybe in order to print it directly. So I'm smoothing here my cutting surface. I'm going to simplify it, and I'm going to export it. Right now in that version, we can export here an STL file. In the future versions, we'll also be able to export an OBJ file. This will be available within that year. We hope that we can see that new version in summertime. Okay, so I save right now this STL file. Okay, and by going back for my CreoParametric environment, I can just open here the saved STL file. This is that guy here. I'm getting the new topology. Of course, here I can maybe mirror that one, because I was calculating the half of that part, and here I can see the behavior of my component, or the shape of my component. Now within CreoParametric 1, 2, 3, 4, or even in Creo or Pro Engineer Wildfire 5, we can use this topology optimization. So all the functionality I showed right now from topology optimization is available from Pro Engineer Wildfire 5 on, and it can be used until Creo 4. And in the newer version, I just will show that here, ProTOpCI also provides the capability to export an OBJ file. An OBJ file can be imported here in the freestyle feature. Freestyle feature is free for everybody with a CreoParametric license, and here we will have, let's say, then the new, or we'll have the new capability importing a mesh, and we can import here the OBJ mesh. Okay, and an OBJ mesh, as you saw it right now, I imported Mickey Mouse. Might look like that here, and when I'm having here the Mickey Mouse, then I could even go in and, let's say, modify some areas of my Mickey Mouse, and with that capability we can, let's say, bring over our optimized part, or maybe just some shapes of the optimized part, to Creo CreoParametric, and in CreoParametric, with the help of the OBJ file, we can create B-rep geometry. So that brings me, let's say, back to the nearly end of my presentation. We saw right now in the real ProTOP environment how we can, let's say, optimize our lattice structures in order to get a bionic component, lightweight component. And before we saw, let's say, the capabilities of the CreoParametric lattice feature. Good, because we are quite a lot of people in this call, I'd like you to ask if there are any questions over the chat panel. The chat panel, you should be able to find it somewhere right down in your GoToWebinar applications. If there are any questions about this webinar about lattice structures in CreoParametric and ProTOpCI, please type in your questions in the chat panel. Otherwise, you also can send me an email. Here is my email address. I think we're just waiting a few minutes. I can't see right now some questions in the chat panel. So there is the first question: can Creo 4 optimize lattice structure by modifying parameters? Yes, as I told you before, I mean a real, I'm going back here in my presentation maybe to that slide here, a real optimization is, in my opinion, is not possible, because you just can take, let's say, the dimensions. These are the dimensions coming from the lattice feature of CreoParametric, and you just can say, okay, this dimension will be modified between a minimum and maximum value. And you have to set, let's say, a start value here. And imagine if you are, let's say, changing maybe 20 of that values, an optimizer will not be able, let's say, to find the global minimum or maximum. Of course, you could imagine to do, let's say, 5,000 experiments with the help of behavioral modeling in order to get a better solution. Yes, that might be possible, but in the end, your optimized part will still have, let's say, that shape. So it still have that shape, and all, let's say, the beams will be kept. They just can be modified. So we cannot take away some beams or some shells, as I showed you in, let's say, the real, I call it Bionic Optimization environment. Here in ProTOpCI, the shells, the beams not needed can be taken away easily. I hope this answers your question. Okay, maybe there is another question. Let's wait a minute. And as I told you at the beginning of the presentation, I think not all of you were already in the call. I will send out later on a link to the recording of the webinar, and I will send out the presentations as a PDF. And if you need some, let's say, additional information about this webinar, you just can contact me by email. So I think we have no more or additional questions. So I'd like to thank you for your time. I hope the webinar was interesting for you, and I hope you know now what are the capabilities in PTC Creo 4.0 with this new feature, with this new lattice feature, and I hope you have also a quite good overview about the capabilities of topology optimization within CreoSimulate with the help of this additional tool from CAESS. Just the last remark, this capability is only available in 4.0. This capability is available since ProEngineer Wildfire 5, and it also supports Creo 4.0. Thank you very much for your time and enjoy your lunch. Bye-bye.